I'm recording this in case you guys want to hear this again tonight. Okay? We have minutes, hours, and miles. Of those units, what can we convert? What can we convert? Keely.
Minutes and hours.
Minutes and hours. These two, correct? Miles is kind of like, it's its own different category. You can't put those together. So let's take a look at those things involving miles and then minutes. For the first one, we talked about where they parked. 7/8 miles. We can't do anything with that, right? No. It is what is. 3 1/4 miles per hour. Can we do something about that one? Yeah. Oh yeah. Okay. Now you have to decide. Are we going from hours to minutes, or minutes to hours? Which one do you want to do?
Minutes.
Ooh, that's a lot. Let's raise your hand if you think hours to minutes. Okay. Raise your hand if you think minutes to hours. Okay. Now I want to point out both do work. However, what did I say in class that should trigger a memory? It's easier. Jasek, what up? Go to the smaller units, right? The smaller units suggest better comparisons and whatnot. Okay? So you want to go from the hours to minutes. So let's rock and roll. I thought there was a step last time, and we like improper fractions more, don't we?
Yeah.
Okay? So you have to consider, of the information that we have 3 1/4. How do we convert 3 1/4 into improper fractions? Pavan?
3 times 4 plus 1.
That C method, right?
Yeah.
The first one is multiply, and the other one is adding. This is what you learned back in the days. And that gets us what?
13 over 4.
13 over 4. So now we're starting to get all the pieces of the puzzle to kind of work together. Okay? You with me so far, guys?
Yeah.
Okay. So we have 13 over 4. We have to convert 13 over 4 miles per, and we don't want to do hours anymore, right? Before it was hours, but we want to get rid of that. So what would it be? Per what? How many minutes, though? How many minutes in 1 hour?
60.
60. Now, this is what they technically do. You do divide it by 60, but I need to show you mathematically what happens, okay? Technically, you have 13 1/4 miles per hour, right? And what we do is you technically multiply it. Now, this is what we call dimensional analysis when we multiply the units out. Some of you guys probably won't know what I'm talking about, but what I'm saying is, for the thing that we multiply, it has to be what we call a true statement. Okay? What that means is I want to get rid of the hours. Remember, if I had something on the top, if it was 5 over 5, what does that become, mathematically speaking? And if 1. 6 over 6 is?
1.
Time over time is?
Time.
Ryan over Ryan is?
Ryan.
No. Ryan over Ryan is? 1. Okay? Anything over itself is always going to be 1. So here's the thing. Our answer, we want miles per what? No. Minute. We agreed. Didn't we agree before that it's minute? So this hour has to disappear. Now we just can't make it magically disappear. We can't assassinate what an hour is, right? We're not like that. We're in school, for crying out loud, right? So we have to divide it out mathematically. Now notice, where's the minutes? Is it on the top or bottom? Huh? Bottom. Guess what? Minute's going to be on the bottom over there. Now, on the top we have miles. We still have this one missing spot right there, right? So, what do you think goes there? Go ahead, Rossi.
60 minutes.
Okay, well, 60 minutes goes right here. You're absolutely right. But what goes on the top? Hmm.
1 hour.
Ooh, I like it. 1 hour. Now, okay, let me pause for a second and talk about this. Notice, is this a true statement? Is 1 hour the same thing as 60 minutes?
Yes.
Okay, I want to point out, if that is a true statement that those two are equal, you are good. Right? Now, when we multiply this across, look what happens. Hour divided by hour. Remember we did the cross simplify that Storm mentioned? Isn't the hour gone? what's left over? Miles and minutes, right? And then what you do is you multiply across, and then that gets you, I'm going to change the screen, okay, guys?
Yeah.
And then it's basically 13 over 4 over 60. Okay. Now, some of you guys are just thinking, well, why don't you just tell me to divide that by 60? Because I had to mathematically explain why. Does that make sense? Because before all we did was replace the 60 with 1 hour. Yeah, that's what you do. You just can't magically do it. It's because it's the same. All right. You should know how to do this, correct?
Yeah.
Someone tell me. Shark? KFC. Woohoo! You guys know I'm recording this?
Yeah.
So I'm going to post this on YouTube and
Yeah, that's right.
in case you need to be on there. It's not public.
We should post the advisement video that we're going to do on
Let's not all get all too excited. I'm doing this because if you forgot, you can watch this video and kind of help you out. Trust me, I don't like doing it because I hate how I sound on video, okay?
I just say Pavad is awesome.
Y'all laugh. No, you just did.
Yeah, you just did.
Moving on. Shh. We're saying that and Shark said KFC, so it's going to be multiplied by what? Was that Avery? 1 over 60, right? Hey, it looks the same thing as before. So let's go ahead and do it. 13 times 1 is? 13, right? And that's going to be 60 times 4. Now everyone's getting their calculator out. Oh, wow, some people are fast. 200 what?
240.
Oh, yeah, just 6 times 4, right, with the 10. Okay, now can this be reduced? It can?
No, it cannot be simple. Really try.
You can try. You can do 240 divided by 13. Sometimes it's worth trying it out. Now, can someone convert it to decimal form? Just kind of, I need to know what it is. What's 13 divided by 240?
0.54.
0. Point what?
54.
54. You went to the 10th. Give me the 100th.
1.
1. Okay. So this, what does this represent? This is how many miles per minute. Isn't it? I'll be honest with you. That's pretty darn fast.
This is starting to make sense.
That means you can go ahead. You can go at you can run half a mile in a minute.
No, that's the world record. That's like a world record right there.
Walking. Now it's starting to make me wonder if this is right or not.
That's pretty fast.
Wait, show the answer.
Well, right.
Wait, I have a question.
You can't run a mile in like a half mile in like a minute.
Huh.
You can.
Hold on. There has to be something that we're not doing right here.
Yeah, because that's the way.
Well, wait.
Okay. Now we know the mistake. We forgot a whole 0. That made no sense. Apparently I just can't hear. 0.054. Now it makes sense. Okay. I was like, that's humanly impossible.
Is that a 1 next to the 4?
Yes, that's correct. Okay. Shh. Okay, can someone tell me, what does this represent? What does that number mean? Yeah?
The amount, the miles per hour.
That's just the speed, right?
Yeah.
Per minute. That's all it represents. So now that we have the speed per minute, let's see if we understand the problem. Okay? It says this. There's 2 components here. We have the car. Look at my awesome car. Okay?
Nice.
And then
Nice.
you got the big old stadium. Woohoo!
Nice cake.
Playing football because that's the only sport that we talk about here.
It looks like a can.
Okay?
It looks like a Lego trying to
Okay,
drive
before
to
we make fun of
pizza.
Mr. Lowe's drawing, let's solve the problem, shall we? We say that this is 7/8 miles. Okay? Now the game starts in 14 minutes. So how do we figure out if the person makes it or not? Who remembers that one equation that we talked about involves a D?
G.
Hands, please. Storm?
So distance equals rate times time.
Fantastic. Now that we have that equation, and you should all know it, what are some information or bits of information we can put in there? What is our rate? Yeah?
0.054.
Yeah. Our rate is technically the 13 over 240, isn't it? I'm going to keep it at 13 over 240 because it's exact. The other one is rounded, so I'm just going to keep it like that. If you did 0.541, technically it could work. Do we know the time?
Yes.
Okay? We can multiply that by the time, 14 minutes. Fantastic. Okay? So now we have 13 over 240 times 14. That would equal the distance.
Is the 14 technically over 1?
Yes. Good job, Wiggs. It is, distance is equal to 13 over 240 times 14 over 1. So now we're in business here, right? Someone with their calculators, 13 times 14, help me out here. Okay, hands please, don't shout it out. Pick Turna, this time give me a good calculation.
182.
All right, confirmed with Schaefer's calculator I'm standing over right now. All right, so we have 182 over 240. Can someone tell me what 180 over 240 is?
Oh, wait. What?
182 over 240.
Wait,
Yep. Did I do something wrong?
don't you do KFC?
Don't you have to switch
We did.
the 14 and the
No, you don't. Huh?
Oh.
Oh wait, no.
You do not need to switch it because are we dividing? When do we do KFC? When you divide fractions, and we're not dividing it, right? So 182 divided by 240 is
0.75.
0.75. Give me another one.
8.
8. Okay. If I simplified 182 over 240, does anyone know how to do that one? This is just good. That's an extra bonus. You could divide it by 2, which gets you what?
91.
120. Okay, interesting. Now, what unit is that? That's 0.58. Remember, what did we equal? It equaled the look, distance. Very good. So what's the distance measured by? Novello? Good. So this is miles. All right. We did the hardest part. We're almost done. We're actually pretty much done. The question is, can we answer the question?
Yes.
What we did, we used this distance equals rate times time formula. We calculated at our current speed, if we walked for 14 minutes, we can travel 0.58 miles. So the question is, did we make it to the stadium on time?
Yes.
How do I know that? Let me ask you this. How far is the stadium from this? How do I know? Novello, again?
Well, it's 7 and 8 miles.
Whoa! We have to look at the problem again. She's absolutely right. Right? It's 7/8 miles. Can someone calculate 7/8 for me?
Wait, like divide them?
Yeah.
Oh, it's...
I got it.
0.875. 0.875.
Okay. Let me ask you this. Okay? 0.875 miles. That is how far you have to walk, right? How far can we make it? 0.75, what was it, 1? 8. Did we make it in time?
No.
Guys see it? We done.
That was actually wasn't terrible.
Okay? It wasn't that bad, was it now? Okay, now the light bulb's going off for some people. Because what they're saying is, this is how far we can go with only 14 minutes. But in reality, the other number right here, that is how much we need to go. There's just not enough time. Right? Other than that, you have to somehow get faster. You know?
You have to run faster.
Okay, let's see. Okay, for those people that are at home that know how to use the book, okay, if you hit the show answer, let's see what they got right there. Oh, look, they said no as well.
Oh, we're smart.
Well, now look at the book. The book does it a different way. Okay,
Yeah, let's go.
okay, it's fine. It's totally fine to solve it 2 different ways. Okay, we went ahead and did KFC. What they did is they figured out how many. They converted to hours instead. We did it to minutes. Remember? Okay, they did 7/30ths of an hour. Was how much time they needed to get there. Both different method, same answer. Okay? If this was the quiz or the test, had you done one or the other, and then during the test you just raise your hand, say, Mr. Lowe, I did this way, I'll check it, and if it's right, I'll give you credit for it. Okay? You don't have to do it just one way. Good?